a load factor of 0.75 and a hash map of size 10, then whenever 75% of the hash map is full, then we want to resize, so double the size of our hash map. What this does is pretty much avoids it avoids like a lot of collisions between the nodes, so it avoids having super long node node chains, so that the really cool part about a hash map is that you can access the nodes very easily if they're spread out evenly. If they're not spread out evenly, then it can get hard to access nodes that are like super far down the chain. Down, like, for example, if there's like, let's say 100 nodes, then it's like super hard to go and find all of those. What we want on our hash map, so load factor, the size is going to be how many buckets have a node in them. So, and then we have a key set. So a key set is just going to be all the keys in our hash map. And then we have this buckets or table. I know a lot of people call it a table. It's an array that inside contains a bunch of array lists. And what those array lists correspond to is pretty much node chains. So that's all the conceptual stuff behind the hash map. And then now we will go through the coding one. Sweet. All right. So can everyone see this? So I already wrote like almost half of it just for like time's sake. So our class hash map is going to be taking keys and values, and it's going to implement the map61b interface. And by the map61b interface, it's all of these methods, and we have to implement all of these except the remove method, which the remove method is just optional. So the first thing we want to do, since our hash map takes in a bunch of nodes, is create a class constructor for a node object that takes in a key and a value. So every single node that we have is going to have a reference to its key and its value, hence key value pairs. And then there's a couple instance variables we want for our hash map. The first one is our buckets or our table. This is going to be like an array representation of our hash map, and inside are going to be array lists that take in a bunch of node objects. We want to be aware of the size of our hash map, the load factor of our hash map, and then we want our key set, which we're going to instantiate as a new hash set of k object. Sweet. And then what we want, I just declared two static variables called the default initial size and the default load factor. And those will be just in case we call on the constructor with no specific size or load factor, then it's going to automatically make those. And then I have three different constructors. I have a hash map one that takes in an initial size and a max load. And then what we do is we instantiate our buckets array list. We instantiate our size to be 0, and we set our load factor to be the max load that came into the method, and we have a new hash set of keys. And then these two constructors are just in less specific cases. So if we only give the initial size, then we're going to call this, which is this constructor over here. When we call this, it calls the more specific constructor with our initial size and the default load factor. And then same thing with this constructor. We have an initial size. It takes in nothing, so we're going to simply call this on the default initial size and the default load factor, and it's just this method with the initial size set to the default and the max load set to the default.
I have a question.
Mm-hmm.
So how come, can you just, when it's like an instance variable with this, you can just put it in parentheses? You don't have to do the dot?
So by doing this, when we call this, since this constructor has the exact same name, when you call this with the two arguments, it's pretty much says call like myself, because these two have the same name. They're the exact same constructor. It's just that this, when you call this with two parameters, it's going to call the method with the same name, but that has two parameters in it. It's kind of a weird like use of this. Weird. Yeah, but it's a pretty like nifty use of this.
Oh, I could have just done it normally though, right?
Yeah, you can do the exact same constructor, but instead you just like set the, you can pretty much copy and paste this into all of these.
Yeah.
Make like two different constructors if you want, but this is like the
way bigger. I put
your way of doing it. Yeah.
I put this dot buckets and like this dot size and
yeah, that's fine. Yeah, you can do it. I actually do like using this keyword a lot. It just like makes it clear that you're sending like the specific hash maps
Uh-huh.
to these variables. All right, so let's go into the clear method. So the clear method, what it does is pretty much resets your hash map to be just nothing, so to be like empty. So there's three things you want to do. You want to change. Clear will not change the load factor. The load factor will stay. The things that will change are the buckets. So you're just going to set buckets to be an array list. I'm just going to copy it from here. The same constructor, but this time it's going to be the default size, default init size. And then we're going to reset the size to be 0. So we're going to set size to be 0, and then we're going to set keys to be a new hash set again. To be a new hash set. And yeah, so now that resets everything. We have an empty buckets, we have empty keys, and we have a size of 0. The size method is simply just going to return the size instance variable, and the key set method is simply going to return the key set variable too, the keys set instance variable. Now we have contains key. Contains key, what it does is takes in a key and then checks if it's in the key set. So hash sets have a pretty cool method called contains that just returns if it contains, if your hash set contains that specific item. And then the iterator, so what the iterator does is allows to iterate over a key set. This simply, we're just going to create an iterator that takes in keys, and then it's going to iterate over this key set. So that allows us to iterate over the key set. All right. Now let's go into the get method. So what you want to do with the get method is return the value to which that specific key that we're taking in is associated to. So the way we want to run get is we want to find the bucket associated with that key, and then so we want to find the bucket associated with that key, and then find the node associated that's within that bucket. So the way we can do it is I'm going to create a helper method called, I already created it, but called getNode. And this will actually return the node associated with that specific bucket that is then associated with that key. So the first thing we can do is in the getNode method, we can call a findBucket helper method, which will firstly find the bucket associated with that key. So in this case, the way we do it is I actually created a lot too much, but pretty much we find the key associated with the length of our buckets. And what this is the floor modulus of the hash code, and then the length of our table. So yeah, it's the hash code modulo the length of our table. That's how you find the bucket associated with a specific key. And once we have that index, so that specific bucket, now we can actually work to find the node. So the node that's within that bucket. So the first thing we can do is find the array list that is within that bucket by doing buckets of index. So in this case, we're calling it into our buckets array and finding the array list that's associated. Then what we can do is, if that bucket list is not null, then we can, so if that bucket list is null, then there's nothing to do. There's no node in there. But if it's not null, then we can loop through all the nodes that's within that array list. So for node in bucket list, then if that node dot key equals the key that we're looking for, so if we found the node that has the key that we're looking for, then we can simply return that node. And if we've never found it, then we can just return null. So if you've never found that node in the end, so if every single bucket list is null, or we've never found a node that has the key that we're looking for, then we're just going to return null. So now in the get method, we found the node that we were looking for inside that bucket. So now what we can do is, if the node that we found was just null, so if we actually didn't find the node that we wanted, then we can just return null. And if not, then we could just return the node.value, so the value of the node that we found. So basically with this get method, what we did is we found the specific bucket that we were looking for by using the floor modulus of the hash code with the size of our hash table. And then once we found that, inside that bucket, that's when we loop through all of the nodes that are within that bucket, check if that node the key of a specific node equals the key that we're looking for. And if we do, then we're going to return that node. And if we didn't find it, then we just return null. I'll leave this up for a little bit. If anyone has any questions, feel free. And then we'll go through put.
Wait, what's the node.key? Can you explain that again?
Yeah, so every node that's within our bucket, within our hash map, has a key and a value. So in this method, we're looking for a node that has this specific key. Let's say we're looking for a node with like the key 3. Then here, what we're seeing is we're just checking if the key of the node that we're currently looking at has the key 3, or any key. And if it does, then we want to return that one because we found the corresponding node that we wanted.
Okay. Cool.
Key in the chat. Key equals or dot equals. It's a good question actually. I'm honestly not sure if you can. I'm sure equals could work too. That's a good question. I would just probably stick to dot equals because we're comparing two objects of type K. Do any of the AIs know?
It's probably dot equals because you can also use equals for like non-object sort of things, right?
Right. That makes sense. Yeah. So I would use dot equals. Okay. All right. Let's get into the put method. So what the put method does is it assigns this. So it takes in a key and a value, and it pretty much puts that specific node with a key. It puts the node with that key and value into your hash map, and then you want to make sure that you resize your hash map if you've hit the load factor, like the capacity limit with your load factor. So the first thing we want to do is we want to check if this node is within our hash map already. So that's one of the specific things. We have two cases. So case 1 is that the node exists in our hash map already. Then we just update the value with the specific value that is put into the method. And then if not, then the node doesn't already exist. Then we want to create it and add it into our hash map. So first thing we want to do is make sure that this node, check if this node exists. So if node is not null, so that means that this node already exists in our hash map. Then we want to set the value of that node to be the value that we passed in. So we're pretty much saying, okay, does this node exist? Does this node already exist in our hash map? If it does, then we're going to update the value of that node. And then that's when we can start looking to resize. So you need to pass in size as a double. Okay, so if the size of our hash map divided by the length of our buckets, so if the number of buckets that are filled divided by the total length of our buckets is greater than our load factor, so if we've hit the maximum capacity, so for example like 75% of our hash map, then that's when we want to resize our hash map. So then we can resize it with a length, with a double length. And now we're going to write this resize method that's pretty much going to create new buckets that are twice the size. It's going to create a new buckets array that is twice the size of our current one, and then repopulate it with all of the nodes that we had in our previous hash map. So how this is going to work is we're going to create a new array list of nodes, a new array of array lists, called, let's call it new buckets. It's going to be we need to cast it as an array list of nodes. And then we're going to call it a new array list of length target size. So I passed in target size. It's like the size of our new double buckets. And now what we can do, there's like a nifty trick where you can actually just look through all the keys, in your key set. And in there, what you can do is find the associated index. So we have this find bucket helper method that took in the keys and the length of our new buckets. So we're finding the associated buckets, and now what we need to check is when we instantiate this new buckets array, it doesn't actually automatically create array lists in there. We need to like instantiate those. It's just like when you create, for example, an array of, like an array of integers. They're automatically set to 0. Well, when you create an array that contains array list objects, its default instantiation value is null. So we need to actually populate this new buckets array with a bunch of empty array lists. So if the new buckets of index is null, that means we've just instantiated it. Then we want to set it to a new array list. So we can create a new empty array list of and you know, just set the size. And then what we can do is once we've repopulated this new buckets array, then we can simply add all of the nodes that we need. So we can do new buckets of index, and then we can add into that array list. We can add the node that we got from the previous bucket. Oops. Something. Oh. Key. One singular key. So just to reiterate through that, we're creating a completely new array of size double the previous one that we had. Then we go through our key set, find the associated bucket, repopulate our new buckets array with a bunch of array lists, and then we add the nodes that we need. The nodes that were in the previous array, table array, and then we're going to set this new buckets. To be. We're going to set our instance variable of buckets to be the new buckets that we just created. And so now we've doubled the size of our hash map, and we've only done that in our put method if we hit the capacity with our load factor. And now to finish the put method.
Wait, I had a question about resize.
Mm-hmm.
Can you explain again what index does?
Yeah.
What length?
So, right here.
Yeah.
So what it does is when we loop through our key set, all we have is like a bunch of keys, right? So for example, we have like, I don't know, like 1, 2, 3. So it's a bunch of the keys that are associated to nodes, but we don't know where those nodes are exactly in our hash map. We only know that this is just like a key that it exists in our hash map somewhere, but we don't know where it is. So by doing this find bucket method, we're looking for where that key is in our hash map and where we should put the associated node into our new bucket.
Oh.
Does that make sense, Noah?
That uses like the floor mod stuff?
Yeah, that's the one that uses the floor mod with the hash code and the size of our hash map, and then returns the indicated bucket that we need to put that node in.
Because the index isn't always just like 0, 1, 2, 3, 4, 5, because it depends on like that.
It depends on like what the hash function will do and where it would put your key.
Okay. And then why would you, if it's empty, why would you create a new array list? Like, wouldn't you just... because that's because you doubled it, so you need to populate it after.
Right. And when you instantiate that new buckets array, it's going to be full of null values because that's like the default value for a bunch of array lists.
Yeah.
So, yeah. And then we add all the nodes that we need.
And you add all the nodes to like that's like copying it over, right?
Yeah.
Okay.
Yeah.
Cool.
And then we just set our instance variable to be this new doubled array that we just created. All right. There's no other questions, then we'll finish the put method. So 5 minutes left. All right. So when we put a new node into our hash map, the first thing we want to do is increase the size by 1 because, well, we have one more item in there. And then we also want to add this new key to our key set. So we want to make sure that we update our key set because we just added a node with a new key. And then, same thing as in the resize method, we can say we can find the index that we need to put this node into. So using this find bucket method that just does the floor mod of the hash code. Actually, I'm just gonna just for clarity's sake. Should be fine. All right. Just for clarity, this is what we're doing. We're using the floor mod to find the bucket that we need to place this in. And then after this, we want to find the, so now that we found the index that we need, we can find the array list within that bucket. So it would be buckets of index. Oops. So now we found the bucket that we need, and now we're going to go into that array list and place the node in there. So if that bucket list is null, so in this case we're checking again, just like in the resize method, we're just going to check that this bucket isn't actually empty, because if it's empty, then we want to create a new array list. If it's a null index in that in our bucket list, then we want to create a new array list so that we can actually put the node in there. And yeah, then we can set our buckets of index, buckets of index to be bucket list, or we can actually just do new array list. See the question in the chat. When are you posting the recording? So I'm probably just gonna. I might just send a link in the Discord chat once it's processed. And then what we will do. Let's see. And then what we want to do. So we set this bucket. So if our bucket list was null, so there's actually no node in that specific bucket. So we want to create that new array list so we can actually put the node in there. If the bucket list is not null, that means there's already an array list inside of that specific bucket. So we're good. And now all we need to do is just add that specific node that we were wanting to add. So we create that new node object, and then we just add it into the bucket list. And that is the put method. So basically, we make sure, so we check if that node already exists. If it does, then we update the value. If not, if it doesn't exist yet, then we then we check if we need to resize our hash map. And then if we do, then we do so. And then we increase the size by 1. We add the key to our key set, and then we check the bucket. We check the bucket that this node needs to go into. Once we found this bucket, then we go into the array list that's within that bucket. If that array list doesn't exist, so there's no node in that bucket yet, then we create a new array list so we can actually insert the node into that bucket. And then if an array list already exists, or we just created it, then we just add the new node that we want to create. And that is put. If anyone has any questions, I'll be on the Zoom call for another 3 minutes, and then I will post the recording into the Discord chat, probably just in announcements. Hopefully it'll be done. The recording will be processed in about like 30 minutes or so. So yeah.
What's the arrow that is at the top?
Let's see. Class Hashmap. Oh, it's because I haven't implemented remove yet.
Okay.
So yeah, remove is optional. So if you are not doing remove, you don't really have time right now to go through it. But you can simply just like return like
Yeah, throw an error.
Yeah, I think it's
Throw a new
error.
error.
Yeah.
Yeah.
You can just do like exception. You can do not done. That should get rid of you. Actually,
they wanted the unsupported operand exception.
Unsupported.
Yeah, there it is.
And that still doesn't get rid of it. Oh, there's another method. This should get rid of it. And then just do this. And, oops. Alright, these problems, I think you can just ignore these problems. It seems like everything's compiling fine. Actually, you can probably just do it like that. Still doesn't get rid of it. Oh well. Yeah, so that's the solutions to this lab. I'll post the recording on Discord, and then yeah, have a good weekend, everyone, and stay safe out there.